Hello friends, welcome back to my YouTube channel. In this class, I am going to discuss about the physical significance of entropy and what is its relevance in daily life. So, before that, I must say one thing to all of you. Please do subscribe to this channel. Of course, like it and share it to your friends. So, what is the physical significance of entropy? In the last lectures, we have discussed that entropy is a thermodynamic property, and we discussed about the Clausius inequality. But what is the physical significance of entropy? That means, what is entropy? What is entropy? We must know this. What is entropy? Entropy is defined as, entropy is, in fact, we define entropy like this. Entropy is a measure of molecular disorder or molecular randomness. So in fact it is a measure of disorder or randomness. As a system becomes more disordered means what happens? The position of molecules become less predictable and entropy increases. Any system is composed of molecules. Once the molecules move in a random manner, once the randomness of molecules increases, means the entropy of the system increases. So it is in fact a measure of randomness of molecules, or measure of molecular randomness, you can say. So there are two approaches to study thermodynamics. One is macroscopic and another is microscopic or statistical thermodynamics. So to understand what in fact is entropy, we must have a understanding of microscopic nature of matter. We have to consider the microscopic nature of matter. You see, suppose there are three states in which a matter can exist: solid, liquid, and gaseous state. There are three states in which a matter can exist. In fact, as we progress from this solid state to liquid and then to gas, in fact, the entropy increases in this manner also. The entropy or randomness increases in this order also. Entropy. So, in case of solid, the entropy is the least, and then it is less than the entropy in the liquid state. Then whatever entropy a matter has in liquid state is less than, obviously, of course, when it is at the gaseous state. Because in solid phase, what happens? So this is the diagram is like this. If you draw, this is suppose the y-axis is your entropy, and its unit is, in fact, the entropy unit of specific entropy is kilojoule per kg Kelvin, that is small s, specific entropy. And in fact, in solid state, if entropy on the entropy scale, solid state is here, because this is the state at which the entropy is the least. Then comes the liquid, and then comes the gas. So why the entropy is in fact least in case of solid? Whenever the matter is in solid state, its molecules in fact only oscillate about its present position. Molecules only oscillate. They don't move in a random manner. And as it melts into liquid and later on evaporates into gas, molecules move in a random manner. So we can't predict the movement, or we can't predict the state of molecules in the gaseous state, because the molecules move in a random manner and collide with each other. Whenever a matter is in gaseous state, molecules move at a random manner. In gaseous state, molecules move at a random manner, and and collide with each other, collide with each other, thus making the position of molecules unpredictable. Unpredictable means this results in a randomness. So in fact, entropy increases whenever we are in no position to predict the position of molecules, means the entropy is at a higher level. But whenever a matter is in solid state, molecules only oscillate about their position, and that also fades away with the decrease in temperature. Yes, in the solid state the molecules oscillate about a mean position, but with the decrease in temperature, that also disappears. So entropy is in fact at its lowest level when a solid is in absolute zero temperature. So that is in fact the third law of thermodynamics. That is in fact the third law of thermodynamics. And molecules are nearly motionless at absolute zero temperature. So at absolute zero temperature, the entropy of a pure crystalline substance is zero, So this is the, we can state that the entropy of a pure crystalline substance at absolute zero temperature. What is absolute zero temperature? Absolute zero temperature, that is 0 Kelvin, is 0. This is in fact the third law of thermodynamics. This statement is in fact the third law of thermodynamics. The entropy of a pure crystalline substance at absolute zero temperature is 0. And actually, this provides a reference point for determination of absolute entropy at a certain state. So we must know that the absolute entropy of a pure crystalline substance at absolute zero temperature is 0, at 0 Kelvin, because the molecules become motionless at this temperature. This must be a solid, and it is at a 0 Kelvin. We know that as the temperature increases, the molecules of the solid move, oscillate about their position, thus making the position of molecules a bit unpredictable. But at this lowest temperature, that unpredictability is not there, and that's why the absolute entropy or entropy is 0. And another thing is that with the transfer of heat, why entropy is transferred, why entropy is transferred with heat, but not with work, that is a question to be answered. Entropy is in fact measure of disorder, but heat is a disorganized form of energy. Heat is disorganized form of energy. Disorganized form of energy. Disorganized form of energy. So when heat is imparted to a system, suppose a system is there and heat is imparted to a system, it increases the internal energy of this system. Suppose this is your system and heat is supplied to it. Heat increases the internal energy of the system. So the molecules start moving randomly once this heat is supplied to it. So molecules start moving randomly means its entropy increases with the transfer of heat into it. And if heat is rejected, its entropy also decreases. So that's why that means heat since heat is a disorganized form of energy, it introduces disorganization into the system. It introduces entropy into the system. But that is not with work. Work is a organized form of energy. So disorganized means you can understand in this way also. Suppose molecules in a gas phase have kinetic energy, but suppose we will supply into a container, we will supply some paddle wheel work into a insert a paddle wheel in fact, but this gas molecules inside the, suppose this is a container containing some gas, and we will insert paddle wheel into it. We'll insert paddle wheel into it, but this will not rotate this paddle wheel because you see this gas has kinetic energy, but why is not it, why the gas molecules are not able to rotate this paddle wheel? Just because its energy is not organized. Suppose two molecules will try to rotate this paddle wheel in one direction, another two molecules, suppose in this direction two molecules will rotate, another two molecules will try to rotate in this direction, in this reverse direction, so the paddle wheel will not rotate. So that means this kinetic energy of gas is disorganized form of energy. So heat is a disorganized form of energy. But suppose here is a shaft which is rotating, here is a shaft which is rotating in this direction, and this will carry this weight, this will lift, this will carry this weight in the upward direction because shaft is rotating in this direction, because all the molecules of shaft are rotating in the same direction, so they will try to carry this weight in the upward direction. Unlike this case, this is an organized form of energy work, and this is the kinetic energy of gas or heat supplied to it. Kinetic energy of gas is resulted only when heat is supplied to it. So these are disorganized form of energy. So entropy is transferred into a system with the disorganized form of energy, and entropy is transferred out of the system also with the rejection of disorganized form of energy. So there is no entropy transfer involved with any kind of work, but there is always entropy transfer with heat. So this is very important for calculation of entropy change and entropy generation. So this is all about your physical significance. But what is the relevance of entropy in our daily life? Daily life. The entropy and entropy generation, entropy generation in daily life. So what is the relevance of entropy in daily life? That we will actually understand in this lecture. So you see, entropy we understood in terms of mechanical things, but whether it has any relevance in daily life or not. Entropy means disorderness. The more the entropy in someone's life means, the less successful the person is. Less successful, less efficient his life is. Suppose more entropy, more entropy means will lead to less efficient life. Suppose a student who is much more organized and he is very punctual, he works hard in a daily routine, he maintains a daily routine, and is expected to be more successful than a student who is not at all organized, whose life is running in a haphazard manner. So that means more the entropy is, less efficient is the person concerned. The person whose life is more organized is bound to attain success. That means more organized means less entropy, because entropy is a measure of disorderliness or randomness of the system. In fact, not only in personal level but also in country level or state level, entropy is also very important. The more the entropy means, the less peaceful the country or state is. Once the peace is not there in a country, then the economy will not thrive. Take for example of the country of Afghanistan. When terrorism is there, no foreign investor is likely to come to your country. So that means entropy should be minimized as much as possible, not only in personal life but also in national life also, social life also. Suppose there is a library, there are two libraries. One library, books are organized, shelved, and indexed, and another library, books are in a disorganized manner. So one student would definitely prefer to go to library 1 to find out any book, because he doesn't have to search more to find out the desired book. On the other hand, if he goes to the second library, he will find it difficult to search for the desired book which he wants to. So that means the entropy should be less for successful life. So just like your mechanical aspects, like mechanical friction leads to irreversibilities, and once the irreversibility is there in a process, some entropy will be generated, because we have already studied that entropy generation is possible. Entropy generation is there only in case of irreversible process. In case of reversible process, no entropy is generated. Sgen is greater than or equal to 0. Greater than 0 for irreversible process and equal to 0 for reversible process. So entropy generation means some production of randomness, production of disturbances, creation of disturbances. So फ्रिक्शन, मैकेनिकल फ्रिक्शन होने से इरिवर्सिबिलिटी आता है किसी भी प्रोसेस पे, एंड once the irreversibility is there, once the losses are there, some entropy will be generated. That is also applicable for daily life also. Suppose in an office, if there is a friction between employees, the productivity of the office will be affected. So to ensure productive operation of the office, friction has to be minimized, this friction. Another analogy can be like this: unrestrained expansion. You see, unrestrained expansion is always an irreversible process. We have already discussed that it is an irreversible process. Suppose there are two compartments, and if here it is vacuum, and this is part of this this whole system is suppose punctured, then the air or gas inside this part will rush into this vacuum part, because there is no pressure here. So always a system has to work against pressure. Here there is no pressure, so that's why it is called free or unrestrained. किसी भी तरह की resistance यहाँ नहीं है, free expansion. But this can be proved also that this is an irreversible process. Similarly also, if someone opens his mouth in a unrestrained manner, utters undesirable words against others, living others surrounding him or her, then it will obviously lead to some disturbances. It will always lead to some chaotic situations, because you have to restrain your words. Once those words come out of your mouth means this may go to create disturbances. So unrestrained expansion, or it is also called free expansion, always increases the entropy and creates irreversible situation. If your words have created some disturbances, means the restoration of peace will be nigh impossible, because if you have your words are not proper, then it will create disturbances, and it is hard to reverse, it is hard to restore the peace and tranquility afterwards. So that is, unrestrained expansion is, or free expansion is irreversible. That is applicable both for mechanical aspects as well as for your daily life also. So entropy should be minimized in your daily life, both from personal perspective as well as from social or national perspective. The more chaotic situation in a country, the less the possibility is there for economic growth. So that's why entropy is not only important in mechanical views, mechanical terms, but also for personal life also. So thanks for watching.